Good morning, Year 5, and welcome to Wednesday's maths lesson. So we're going to carry on with what we were looking at yesterday, which is comparing fractions. And we're going to take it to the next stage now, where we're going to compare fractions that are greater than 1. Now, it's largely the same principle that you have to look at, but we will just remind ourselves of them, and then you can have a go at the activities. So let's look, first of all, at our starter activity. Ron makes 3/4 and 3/8 out of cubes. He thinks that 3/8 is equal to 3/4, and you can see why he thinks that. Do you agree? And explain your answer. So have a little think and then have a go at that one first of all. What do you think? Is Ron correct or not? Okay, so hopefully you noticed that the whole that Ron is comparing isn't equal, which means that 3/4 and 3/8 can't be equal in general, because for them to be the whole, both of the wholes would have to be 8 cubes. And that would mean that we needed another 4 cubes for the top one. And if we do that, you can see that suddenly 3/4 is 6 red cubes there compared to 3 red cubes out of 8. So we need to be very careful when we're looking at this, that the whole is the same size. In the same way that if you ordered 2 pizzas, one was a small and one was a large, 3/8 of a small pizza might be different to 3/4 of a large pizza. So we're going to keep on comparing fractions, which means that we're going to look at numerators, denominators. We're going to look at greater than and less than again. And this time we're going to be adding in improper fractions too, because we're going to be looking at fractions that are greater than 1. So here we've got 2 improper fractions. We've got 4/3 and we've got 5/3. How do we know which fraction is greater? Now, hopefully you remember from yesterday that if the denominators are the same, then all we need to do is look at the numerator, and then the larger numerator will tell us that that's got a higher proportion of the shape shaded. So here we can see 4/3. 1 whole is 3/3, which is why I've got them as 2 wholes there. So it's 1 whole and 1/3, and this one is 1 whole and 2/3. So I should be able to tell that 5/3 is greater than 4/3. If the denominators are the same, we can compare fractions by looking at the numerators. So again, so let's try again with this one. We've got 9/5 and we've got 6/5. Now I can see straight away that the denominators are the same, which means that all I need to do is look at the numerators. 9 is greater than 6. So I can show that with this, but I can also check my working. So here I've got 9/5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here I've got 6. 1, 2, not that bits. 2, 3, 4, again, 4, 5, 6. And I can see that 9/5 has clearly got more of those fifths shaded in. Now, what about if the numerators are the same, but the denominators are different? So here we've got 9/5 and we've got 9/7, and we talked about this yesterday. The larger the number that the denominator is, the more equal parts the whole is split into. And the more equal parts the whole is split into, the smaller those parts are going to be. So we can work it out by using that. Here I've got my whole split into fifths. Because it's an improper fraction, I need at least 2 wholes, and there I've got my whole split into sevenths. And if I move this across, I can see that both wholes are the same size. Now, if I shade them in, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I compare them, I can see that 9/5 has got more of the shapes shaded in than 9/7, because a fifth is larger than a seventh, which means that our symbol here needs to be this way. There we go. If the numerators are the same, we can compare the denominators. The larger the denominator, the more pieces the whole is split into, meaning it will be smaller. So let's try another one. I can see that the denominators are different. That's always the first one I check. However, the numerators are the same. I can see that 1/4 is larger than a sixth, which means that 8/4 is going to be larger than 8/6. So I can do that. I can also check it using my bar models. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I can see clearly that 8/4 is exactly the same as 2 wholes, whereas 8/6 is less than 2 wholes. So 8/4 is going to be larger. What if nothing is the same? So if nothing is the same, then what we need to do is we need to try and make something the same. Now, in this case, it's going to be the denominator. If I look at the number 4, I know that if I multiply that by 2, then I can get it to 8. So I can find the equivalent fraction. You can check with the bar models as well. So from looking at the bar models, I can see that both of them have got a whole. And then all I need to do is compare the other bit. So I can see that 7/4 is greater than 13/8. But I can also find an equivalent fraction. So I know that if I multiply the denominator by 2, then it ends up being 8, and I want both of the denominators to be the same. I need to do the same to the numerator, and I can see here that 14/8 is exactly the same as 7/4. It's just represented in a different way. 14/8 and 13/8 are much easier to compare because they've got the same denominator. I can see that 14/8 is going to be greater than 13/8. So let's have a little look at another one. Now this one is slightly different because there's not one sum that I can do. So what I need to do is I need to find the lowest common multiple of 4 and 7. Now I always, let me see if I've got anything there. I always try to use the denominators because I find it easier in my head for that. First of all, I'm going to use the bar model so that I can check to see what the answer is. So 6/4 and 10/7. 1, 2, 3, 1, 2, 3, 7, 8, 9, 10. Now then, so I can see that they've both got a whole, and if I compare the other bit, the bit that's left over, I can see that 6/4 is going to be more than 10/7. Now, the lowest common multiple of 4 and 7 is what I need to find if I'm trying to use it as equivalent fractions. So I'm going to write out my 4s just over on this side. 4, 8, 12, 16, 20, 24, 28, 32, 36. That'll probably be enough, but if I needed any more, I can add them in. And I'm going to do the same for my 7s over here. Let's move my head into the middle. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. That'll probably be enough, but again, we can add more in if we need. Now, if I look through both lists, I'm looking for the smallest number that is in both times tables, and that number here is 28, which means that I need to turn both of these fractions into their equivalents with 28ths. So I'm going to have to do something to both sets of fractions. Now, on my left fraction, with 6/4, to get from 4 to 28, I need to times by 7, which means that I need to do the same to the numerator. So I know that 4 times 7 is 28, 6 times 7 is 42. I am gradually getting better with this. So 42/28 is the equivalent fraction there. Now, to get from 7 to 28, I know I need to multiply it by 4. Let me move him over there. So I need to do the same thing to the numerator. So 7 times 4 is 28. 10 times 4 is 40. Oh, that was actually quite a good 8. You see, I'm surprised by it. And I can see that 42/28 is going to be greater than 40/28. It ends up being a bit faffy, but it is quite an effective way of doing it. So let's have a look at what your activities are going to be today. Again, 3 levels of activity plus a challenge, which is going to be going up on as an ordering activity. So for challenge 1, you've got the bar models all done for you. So 8/5 and 7/5. I can see that 8/5 has got a greater number of squares shaded in. So that one is going to be my greater number. For activity 2, exactly the same, except you haven't got the squares shaded in. So I need to shade in 7/5 for this number, 1, 2, 3, 4, 5, and then 2 more. And 6/5 for this number, And hopefully you can see that 7/5 is greater than 6/5. And then in your third activity, very similar again, but this time you haven't got the bar models to help you. So for my example here, I'm going to insert a text box so that I can make the equivalent fraction. He says, where are they? There we go. Now, if I look at that, I know that I'm going to try and get 4 to be 8. I need to times 4 by 8 to get that to be equivalent. So I need to do the same to the numerator. 7 times 2 is 14. 4 times 2 is 8, which means that 7/4 is the same as 14/8, which is greater than 12/8. Have a go at those challenges. There is also going to be a challenge 1, like I said, where you are ordering fractions using the Teams quiz. But have a go with them. Use yesterday if you need to help as well, and good luck.